Hi, in this video, we're going to learn how to calculate confidence intervals to estimate the population mean. So first, let's look at some of the notes that we already went through and look at some examples that we worked using both the formula for confidence intervals as well as the TI calculator. So if we're looking at this example here, example 5, cereal box weight, it says a machine that fills cereal boxes is supposed to put 20 ounces of cereal in each box. A simple random sample of 6 boxes is found to contain a sample mean of 20.25 ounces of cereal. It is known from past experience that fill weights are normally distributed with a standard deviation of 0.2. Construct a 92% confidence interval for the mean, and you can see we did this with the formula, and we found that the mean cereal box fill weight, was between 20.107 and 20.393 ounces, which was over 20. So I want to find the same thing, but use Rguroo. So let's just identify the statistics that they gave us from the sample. There are a sample size of 6 boxes. That's a very small sample, but it does say that the fill weights are normally distributed, so it's okay that it's small. The sample mean was 20.25, and then notice the standard deviation they give us is not from the sample, it's from past experience. So that means that it's a population standard deviation, a sigma 0.2. So what we're going to do is we're going to go over to Rguroo, and on the left hand side you're going to click on analytics. And in the analysis drop-down, you are going to choose mean inference. And when you choose that, it gives you the options for one population or 1 and 2 population. So we're going to choose 1 population. Now, you can calculate confidence intervals using data sets that you already have, but if you just want to put in your own statistics, like we need to do here, don't select a data set. So ignore the data set, and the sample mean, put 20.25 because that was the sample mean fill weight of the cereal boxes from the sample. And then the standard deviation they gave us was from past experience, so that's the population standard deviation. Notice you have a population standard deviation and a sample standard deviation. You need to make sure you put it in the correct place. This is population standard deviation, so 0.2, and sample size is 6. We're going to leave sample standard deviation blank because they didn't give that to us. And then this is very important. You have to label what we're estimating the mean for. So this is the mean of the cereal box fill weight. All right, so then there are 2 tabs here, confidence interval and test for hypothesis. We're going to leave it confidence interval, and you just have to put in the confidence level. So let me just look again. Oops. Our confidence level was 92%. So I'm going to change this from 0.95 to 0.92. And then for method, you need to choose either T statistic or Z statistic. So this is very similar to the way we did it with the TI calculator. It's going to be a Z statistic if they give us the population standard deviation, and a T statistic if they give us the sample standard deviation. Since we know the population standard deviation, we need to go with the Z. And then when you're ready, you hit the preview button. And there are several things that they give us. So first you see a data summary. It tells you the variable, cereal box fill weight, sample size, mean, population standard deviation. This is just a summary of what we entered. The items we're going to be looking for our actual confidence interval is in the table below. And so at the top, you see above this table, you see it's 92% confidence interval. So that's what we were looking for. And they give us the variable, the mean, the standard error if we were to calculate that, the margin of error on the end if you wanted to calculate that. But what we really want to look at is the lower and the upper CL. So it's the lower boundary of the confidence level and I'm sorry, confidence interval and the upper boundary for the confidence interval. So it says it's between 20.1071 and 20.3929. So if we go back to our notes, you can see we originally got 20.107, 20.107 for the lower, and 20.393 for the upper, and that's exactly what we got here. If we were to round 20.3929, that would round to 20.393. So same exact things, just another type of technology to help us with that. Let's do another one. A college admissions officer takes a simple random sample of 100 entering freshmen and computes their mean mathematics SAT score to be 458. Assume the population standard deviation is sigma equals 116. Construct a 99% confidence interval for the population mean score. So this is the population mean score for the SAT mathematics test. Sample mean is 458. They gave us the population standard deviation again, that's 116. Sample size is 100. So those are the three things that we need. You can see here that we got the confidence interval was between 428.118 and 487.882. So let's see if we get the same thing with Rguroo. So I'm just going to go back to basics and I'm going to just change all of this out. So I believe it was 458. And then the population standard deviation is 116. Again, leave the sample standard deviation blank. Sample size was 100. And I believe the confidence level was 0.99. Yes. And we need to change this no longer fill weight. This is the mean of the math SAT score. And make sure I choose Z statistic again. And here we go. Our lower boundary is right here, 428.12. 428.118 rounds to 0.12. And then 487.88. And look at there. That's the same thing we got. Okay, so you can see that you can do these rather quickly. You can go back through all of the notes that we did earlier, and you can try all of these, and you're going to see that you're going to get the same confidence intervals that we got with the formulas and with the TI calculator. Now, going over to the T distribution, confidence intervals where basically the population standard deviation is not given, the sample standard deviation is given instead. Let's look at a couple of examples here. So potato chip bag. It says the potato chip company wants to evaluate the accuracy of its potato chip bag filling machine. Bags are labeled as containing 8 ounces of potato chips. A simple random sample of 12 bags has a mean weight of 8.12 ounces with a sample standard deviation of 0.1. Construct a 99% confidence interval for the population mean weight of the potato chip bags. So they're giving us 8.12 is the sample mean. And then the standard deviation, 0.1, is, it says it's the sample standard deviation, but you can also see that it's in reference to these 12 bags, which is a sample. So this will be a sample standard deviation this time instead of a population standard deviation. So I'm going to go back to basics, and then I'm just going to change all of this data that I put in. So 8.12 is my sample mean. And my standard deviation for the sample is, I'm looking at the wrong one, sorry, is 0.1. So sample standard deviation, 0.1. We're leaving population standard deviation blank, and I believe the sample size was 12. It was. And this is the mean we're estimating is the population mean weight of bags of potato chips. So the mean of the weight of bags of potato chips. And our confidence level was 0.99, which is what I already have in here. Now, because they gave us the sample standard deviation rather than the population standard deviation, we need to change our method to t statistic. So we'll take that off there, and then we will do our preview. What did I not? Oh, I need to undo the population standard deviation. The sample size was 12. Sorry about that. I put that in the wrong place. Okay, try it again. And we get 8.03. So 8.0303, same thing that we got here. And then the upper boundary is 8.20966. 8.2097, which is what it would round to. So yeah, same exact thing. So just the big thing here is you want to pay attention to whether or not you are given the population standard deviation or the sample standard deviation. And if you're given the population standard deviation, you want to go with a z-statistic method. And if it's a sample standard deviation given instead, you want to go with a t-statistic method. Okay? All right, so if you have questions, please let me know.